Okay, I'm going to try to explain the computer model we're going to be using this week to explore what's happening in the Serengeti with the buffalo population. Our questions this week are to investigate how changes in the climate or the rainfall are affecting the buffalo population, and also we're going to model carrying capacity for just a typical animal population based on a lot of resources available. So in this week's activities, you're going to use this simulation for two separate parts, and you can get to this simulation from a link off of the assignment. So I want to walk you through how to use some of these tools, and then we'll take a look specifically at investigation 1 and investigation 2. So at the top here is the model speed. You can grab this slider to either speed up or slow down the model speed. I have it set to go as fast as possible, and you can kind of still see what's sort of happening here. Um, there's some default settings that you're going to want to make sure are correct. So in the first part of investigation 1, we have this buffalo fence checked, and there'll be some fences that pop up separating the southern and the northern regions. And so this compass needle here, north is to the right and south is to the left. And you want to start with 100% grassland in the central region, so we can adjust the percentage of grassland. So really that's available food by using these little sliders here. And you can see how it will adjust to percentage. It doesn't actually update though until you hit the setup reset button. So I'm going to put check for buffalo fences, no seasonal rains. I want to visualize the raindrops, and I want to not have any wildebeest in this model. So I hit the set reset button, and what you'll see, it takes a few seconds, and wait for it. I'll pause my video while I wait for it. Okay, there it went. So the fences appeared. So what we're saying here is the buffalo are not allowed to migrate. So in our first simulation, we're just looking at a concept called carrying capacity. So we close off this environment. The northern area receives more rainfall. That's why it has this kind of bluer color to it. And that's this visualized raindrops business. And so we're going to start with 50 buffalo. I think you're supposed to start with 40, but the way I'm going to start it is with 50. And then when I have it all set, I just hit this go button. And the go button, you start to see the buffalo just kind of move around, and they're eating the grass. So these little green squares represent the grass. And the grass will regrow according to the amount of precipitation set in the model. But what you're going to start to see here is that if I started with a population of 50, it's decreasing. And so what's happening here is this is just a female buffalo model where if she doesn't get some food in a certain number of turns, she's going to die. But if she does get food in a certain number of turns, she's going to have a baby. And so you don't have to do any like computer programming here. You just have to be able to run the model and come to some conclusion. And we want to run the model to at least 1,000 or 1,500 ticks, I believe, is what the directions say. So you have to just kind of wait and observe. It'll take a couple minutes to see what happens. And you can probably already see what's starting to happen here is the buffalo are consuming the resources. The population is diminishing. The amount of grass that grows naturally in this area is based on the precipitation values isn't going to be enough to keep up with the buffalo. And so eventually the buffalo population is going to die. You'll find out whether or not it goes to 0. I'll stop my simulation. I don't want to give away the answer yet, but you'll be able to see what happens. The second part of the simulation, so I'm going to pause it. And I'm going to change some of the parameters. The second part, you can take away the fences and add some seasonal rains, and that's going to allow the buffalo to do some migration like they're able to. This is more representative of the Serengeti. And um, we'll keep our model speed up as fast as it'll go. We don't have any wildebeest in the mix yet, so we're going to add competitors in the second module. We'll visualize the raindrops, but the seasonal rains, I want you to pay attention, this kind of greenish, bluish color, that'll kind of move over to the south and then back to the north, and that'll affect where the buffalo are wanting to go. I'm going to start with 50 and no wildebeest. I haven't talked anything about this in disease component to this model and vaccine. We'll just leave it, as is. What it's saying is that, some of the buffalo naturally get sick, and um, these are kind of natural conditions. There's this vaccine box, which we should probably uncheck because we don't want to be messing with the buffalo yet. We might try that a little bit later. So we're not going to infect any more than 25%, and then we will go back to reset, and then it'll take 30 seconds maybe, and you should see all those parameters change. So the fences should go away, and the simulation should restart. So I'll pause my video while I wait for this. So right after I paused my video, of course it worked. So then to actually start, remember we hit this go pause button, and we'll just kind of see what happens. The buffalo are eating some grass. We've got some seasonal rains. It's getting darker over here is what that's showing. So it's rainy to the north. Buffalo are consuming the resources, so now they're going to start migrating. And we have a 25% infection rate for disease. So the population isn't going crazy right off the bat. And so when you guys are doing your assignment, I'm going to pause the simulation here. This is something, you can play around with. You can actually explore quite a bit more than just the directions to the assignment. But if we go back to your assignment, okay, the first investigation was just looking at population time. So it says to do some really specific things, starting between 35 and 40 buffalo, run the model, 50 buffalo for 1,500 units of time, and it says to sketch your graph. So the nice thing is, when we go back to the computer model, you can just sketch out what the model produces. You don't have to actually graph it, just sketch what you see. And you'll need to, include probably a picture in your assignment to sketch those graphs, unless you have some sort of paint program that you want to copy and paste into the assignment. So I've kind of walked you through how to do this. It's pretty straightforward, and it says to repeat 4 to 6 times. You probably don't have to do that much. You kind of get the idea if you go a couple times. And so make some observations, make some sense of it. We'll talk about this on Monday or Thursday for B students. And one of the key ideas in this lesson is this idea of carrying capacity and how many organisms the environment can support based on the resources that are available. And then for the second investigation, that's when we start playing around with um, the fences and the seasonal rain, and we kind of see what's happening there. And we'll talk about if this is the cause of the buffalo population going up, if it's related to climate change, if it's related to the available food sources. And in a later simulation, we'll run the disease. So leave the disease stuff set up at what it is when you start off. I was kind of playing around with it a little bit, but I shouldn't have. So leave that vaccine box checked. Let me go back and show you that. So originally, if I didn't mess with it, leave that at giving them a vaccine because we don't want to kill off the buffalo right now with disease. And what you should see is more of a steep increase in that second climate model. Anyways, I think that's probably about enough to get you started with this simulation. So one final thing, the way I got here was I clicked a link. Here it is, HTTP Serengeti Inquiry Hub. So that'll take you to the netlogo computer simulation, which is set up for you to use. And it should run on your computers at home. I certainly didn't have any problems, but I hope you don't. Anyways, I'm going to paste that link separately too in the assignment on Teams. All right, I have another lecture I'm going to do this week too on some community interactions, just more general ecology stuff. All right, have a good day.